Let's start by looking at anti-malware in IoT devices and how this can help to increase security. Let's get to it. Anti-malware, as the name implies, is a piece of software that opposes malware on an end device. It is designed to eliminate the presence of malware. By malware, we're referring to viruses, rootkits, ransomware, spyware, and all sorts of malicious applications on our end devices. With malware, you're able to detect, prevent, isolate, and even remove malicious software from your end devices. Most anti-malware software could be introduced to an end device in different forms, either as a standalone application or as a cloud function that is triggered when a process is initialized on the end device, just as seen when we're exploring cloud computing in the previous lesson. Anti-malware is similar but not exactly the same as antivirus. Both are software options, but there are differences between the two, which we'll touch on a bit later. Now that we understand the fundamental concept of anti-malware, let's explore some key features of this software. It uses advanced malware protection common in technologies such as Cisco Meraki. It uses sandboxing technology to detect and mitigate threats on the end device. It has advanced security features, including the destroying of malicious malware as soon as it enters the end device. And it includes anti-phishing to help protect users from phishing mails. Let's look a little closer at some of these key features. When we look at the working operation of anti-malware, it uses 4 different techniques to achieve its efficiency. They are the following. Behavior monitoring, which is a technique where software programs are compiled using artificial intelligence and machine learning to gather and process user traffic and inspect every packet for every malware-based character or behavior. Now, when malware is detected, it is flagged in real time as a threat. With the use of this feature, the anti-malware scans every piece of data coming in and out of the network. Then we have sandboxing. This technique involves anti-malware software to be able to isolate any application file. Malware software has to be given root access to perform this action. Malware removal. Once malware is identified and isolated, it is totally removed, preventing it from executing and affecting the victim computer. And then you get signature-based malware detection. This technique detects any known malware and also malware patterns from software introduced into the network by comparing a hash of this suspicious code with a database of hashes of known malware. There are a lot of benefits one could gain from using anti-malware software, and some have been developed with an additional security feature to protect end devices. Some of the obvious benefits of anti-malware include the following: prevention, detection, and efficiency. Prevention. Users can prevent malware on their system. An antivirus depends on IOC signatures to be able to detect malware on the system. But more sophisticated malware is polymorphic in nature. This means that these types of malware encrypt parts of themselves to avoid detection. Anti-malware uses AL, ML, artificial intelligence, and machine learning to detect polymorphic patterns in software. Now, these technologies increase the chance of prevention on end devices. Detection. According to the CrowdStrike report of 2019, the majority of the malware incidents that occurred could have been detected and prevented if the system had better anti-malware protection. Being fully able to detect malware on end devices increase the chances of isolating and removing it before any damage occurs. Efficiency. This is a big benefit for users. We know that anti-malware has the ability to identify, isolate, and even remove a malware threat. But the question is, what happens if the anti-malware removes legitimate software from the system? Because of the structural algorithm process of the anti-malware, it goes through multiple verifications to confirm that the software is malicious before completely deleting it. If the software has malicious patterns but is useful to the system, the software is isolated from the system administrator to await confirmation before final removal is carried out. Other benefits include: it can notify a user when unauthorized access is noticed on the system. Privacy protection. So whatever data is collected from the software on an end device is only sent to the right person, not to anyone sniffing information. Threat actors are always after personal information. It can also detect and mitigate zero-day attacks using AI and ML. Sometimes the term antivirus is confused with anti-malware software. So let's explore the concept of antivirus a bit further. Okay, antivirus software is designed to run as an application on end devices to scan, detect, prevent, isolate, and even delete the threat in most cases. When an antivirus is installed on an end device, it serves as a secondary line of defense after the firewall. It is a software that runs automatically in the background to protect the device. There are quite a few highly recommended antivirus options, such as Bitdefender Antivirus, Norton Antivirus, Kaspersky Antivirus, Trend Micro Antivirus, and Avira Antivirus. Note that these software offerings do offer discounts for trial periods, but often require an extended monthly plan to fully utilize all the additional benefits available. A good antivirus will be able to detect known malwares on files and the system. Anti-malware and antivirus are mostly interchangeable. Some modern antiviruses, like Bitdefender, have been redeveloped to become anti-malware software. Here is a table highlighting the differences between the two types of software based on their efficiency and protection. So it may be a good idea to snap and save this table to look at more closely later.